This is our second video on Riemann sums, and I would encourage you to go back and watch both of these so that you can check your answers once you've learned fundamental theorem of calculus. Anyway, let's set this one up. Again, the plan would be that you have already looked at what you needed to for Riemann sums so that this just becomes an example of how to do it with Excel. So I've got using 25 left-handed Riemann sums, calculate the area under the curve for the growth rate of population from 2004 to 2008 if the approximation is valid from 2000 to 2012. So remember, 2000 to 2012 is simply our domain, and then we're looking for the area or the total population using Riemann sums from 2004 to 2008. So here A is equal to 4, B is equal to 8, N, our number of rectangles, is 25. So to calculate dx, remember how we do that? It's simply B minus A divided by N. So our width, or our dx, is 0.16. Remember that x, or the ith, however you want to look at that, that's our counter. That should run from 1 to 25. In this example, I've used something similar to what you see in the lab manual, x sub I, and that just means the x value that we're going to calculate. I want to make sure that you get all of the different symbols so that you're not confused when you see one or the other. So again, x sub I, or our very first x, has to start at 4, our A value. And then remember, it's the cell under that where we actually start our formula. And our formula is simply going to be the value that we start with plus our width. When you come over here to f of x sub I, remember that is simply our population growth rate that was given in the problem. Riemann sums does not involve taking the antiderivative. Remember, we're going to use this to prove that it works. So here again, you're just going to simply type in what you see there. So you can see my original formula typed in. And then remember, the area is the calculation, the function value, that f of x or f of x sub I, multiplied by the width. So if I double click on that, you can see that it's here, G2 times D2. All right. Now remember what this is doing. We're going to look at the area of each of those rectangles. You pause whenever you need to make sure that you understand what's going on. At the bottom, remember how I calculate the sum. I'll delete it here and go back and recalculate it. So you're going to hold the cursor on the cell, click on it that's below the very last area. You're going to go up to auto sum. It tells you that it's going to calculate from H2 to H26. You hit enter and it gives you your sum. So see if you can get yours to look like mine. Go back through and see how I worked through this. I'm going to remove this and allow you to be able to pause the video wherever you need to go back and look at what I've got there. Under this orange box, again, is how we would calculate it using the fundamental theorem of calculus. And that's the next video that you're going to watch, so you'll see how this comes into play. But again, I want you to look at that value, 31.9582, and compare it to what we have. Using 25 rectangles, we're pretty close, but using the fundamental theorem of calculus, we're exact.